All right, everyone, thanks for coming out this morning. Like Matt said, my name's Jeff Elliott. I'm the 3M Fault Protection Specialist for Washington State. If you're not familiar with 3M Fault Protection, we manufacture the DBI Sala protective brands of fault protection, okay? 100% what I do is fault protection. We have other individuals in our division that do hearing, respiratory, eye protection. All I do is fault protection. So that's going to give us the next hour and a half to talk about different fault protection scenarios, okay? Today we're going to mainly focus on our self-rescue pack, how to utilize that out in the field. We're going to do a live demo up on the perimeter limiter, myself and Brandon. And then we're going to come back over to the truck here. I'm going to do some drop demos, show you the actual arresting force on the body on different devices, okay? So we'll do 3 different drops. And then we'll go into our R550 rescue device where we'll run through a few different rescue scenarios, how you would utilize that out in the field, okay? So when I start these demonstrations, I always ask a question. What's the number 1 rule in fault protection? Don't fall. I hear that every day. Don't fall. At 3M, we say the number 1 rule in fault protection is gravity never takes a break, right? Gravity never takes a break. Either we're working on the ground or up there on that perimeter limiter, gravity's always working against us on the body, okay? So whatever systems and equipment you have in place, it's there, 1, to keep you from hitting that lower level or ultimately hitting the ground, okay? When we're thinking of fault protection, we first want to think of the hierarchies of fault protection. If I can eliminate the need to work up there, you don't need any of this cool gear around me, right? Because we can't fall, we're on the ground. But a lot of times we can't eliminate that need to work at heights, so we can do things like deny access to that fall hazard. What are some things we can do to deny access to our fall hazard? Handrails, absolutely. Guarding, barriers. Those are all things we can do to deny access to that fall hazard. But there's times that we get up there, we can't deny that access, right? So we can work in restraint versus arrest. Who knows the difference between fall restraint versus fall arrest? Absolutely. Think restraint like a dog on a leash. I'm restrained. I can't get to my fall hazard. I can't fall over that edge. Now my anchor points might not need to be as strong. My safety plan's not going to need to be as robust because I don't have to worry about getting rescued. I can't get over to my fall hazard. I can't fall. I'm restrained. But a lot of times in our jobs, we can't deny access to work at heights. We can't deny that access. We can't work in restraint, so our last option is to work in fall arrest, like you see up there. Why is that our last option? Because you can still take a fall, right? You can get to that edge and fall off the side of that container. Absolutely, right? So individuals working in fall arrest need to have a much broader knowledge base and understanding of the systems in place being used. You need to know things like what your anchor points are rated for, how often, when to inspect that equipment, who can use that equipment, and most importantly, we need to know what our fall clearances are going to be because we can still take that fall. So that allows us to break fault protection into 5 simple steps, or 6. Your A's, B's, C's, D's, E's, and F's. That stands for anchor point, body harness, connectors, descent and rescue, what we're going to focus on today, education, which we're doing today, and then fault protection for tools, okay? So we'll start off before we climb up there and do a live demo with this self-rescue pack here. This is a new product that we came out with last year. This allows you as the worker to add this to your harness. As you can see back here, I have it installed on my harness. I got a ripcord up here. If you take a fall, this allows you to self-rescue yourself, okay? It comes in 50-foot options and 100-foot options. It's going to, once you deploy, allow you to descend down 1 meter per second. You will land on your feet lighter than if I jump up and land like that. And you will see that here in a few minutes. Very simple device. On the back side here, to connect it to your harness, you have your locking pin. If you have a harness like Brandon has on over there with the EasyLink adapter, you just slide that pin through your EasyLink adapter, connect. Now you guys see this red dial. Everybody see that? Is that secure? No, red is dead. So when you secure this harness, make sure that pin is pushed completely in, okay? And locked in place. You'll have 2 straps on the back of this device. That just straps to your back straps wherever it's convenient for you. That's going to keep this thing from moving around on you, okay? And then this becomes your new connection point for your D-ring, okay? And then you have a cover for your main dorsal D-ring. For inspection purposes, you're going to add this part of your inspection to your pre-use inspection on your harness. So once you put this on, inspection-wise, very simple. You have a flap up here on the front. You're going to open that up, make sure your labeling's intact and legible. Okay, it must be intact and legible. And then you're going to glance inside that screen there, and you're going to see the braking mechanism. That's what's going to be slowing you down during that descent. Okay, so you want to make sure there's no damage there. On the back side, you want to open up the pack and then go ahead and check that there's no cracking in that plastic. Everything's intact. On a real live unit that you're going to use in the field, this is going to be wrapped in plastic. Make sure you keep that plastic wrap. It's going to protect your lifeline in there, okay? And then again, you want to check that housing and make sure there's no damage to that housing there. Now, your shoulder strap here, that's going to come up over your right shoulder, as you can see here, and it's going to hook and loop around that shoulder strap. Normally, you're going to have this rip cord up underneath that flap. Reason why is we don't want to advertently deploy this unit, right? So we want that rip cord up underneath that flap. It takes about 40 pounds of pressure to pull that rip cord. It'll take about 2 hands to rip it out, okay? So if you take a fall, first thing you want to do is you want to make sure your surroundings, there's not a hazard underneath you, right? Okay? We don't want to deploy this unit if there's like a pool of acid below us or a pool of alligators, okay? We want to make sure there's no hazard. So recommendation is once you take that fall, go ahead and deploy your trauma straps, which you'll see me do up there, okay? Once you get your trauma straps deployed, get your bearings straight, now you can go ahead and rip that tab back and go ahead and self-deploy. Now, you might ask yourself, what if I take a fall, I hit my head on the way down, I become unconscious, or I had a medical emergency which caused the fall, how am I going to get self-rescued with this device? Well, your coworker with your rescue pole, this is your main area of deployment if you're conscious. If for some reason you're not conscious, you're injured during that fall, your coworker could come up and use the rescue pole and pull that side ripcord there, okay? Any questions on the self-rescue device?
So what if you're on top of something, you've got maybe, like in our case, false work or something down below, in between your actual fall to the water. If you land on that, are you able to come off of that and continue to descent down to like a boat? Or once you're on solid ground, I mean...
It will stop you, yeah.
So then the controlled descent device that's built in, as long as there's no slack when you come off, it will still continue. Like if you stood on something and took a step off, it'll still pay out at the same rate as it was to begin with. So say this is your working beam here, you land on that, you're going to stop. This is going to stop paying out. If you stepped off the side of that beam, it's going to keep paying out until you got to the actual surface. And so we've got 50-foot devices.
Until you run out of line.
Which
it comes with 50-foot, 100-foot options, okay?
And that's something that you guys, if it's used once, get sent back to you guys?
Send it back to us. We'll get it serviced for you.
Is it annual service by you guys? Or?
There's no annual service to these. What we require is a pre-use inspection once a year by your competent person, okay? If you deploy it during a fall, send it in. We'll get it recertified, okay? Any other questions on this device before we climb up there? Ready to rock and roll? Yeah. All right, I'll follow you. FYI, I have to be dual hooked up per our legal department, so I do have a rescue SRL hooked up to my main D-ring. It's just for redundancy purposes that our 3M makes me do. So, but in real life, you're going to be hooked up right here. Okay.
Does anybody here use the winch, the man winch for these? Yeah?
All right. Go ahead and get some more. All right. So a fall just happened, right? Now, when a fall happens, can we solely rely on 911 as our rescue plan? No. No, why is that? Might not be able to get to you, right? Well, when a fall happens, on average, it takes 20 minutes for 911 to get dispatched out to your site. If you're in a rural area, that could take longer, right? So after a fall happens, suspension trauma starts setting in on average 15 minutes, okay? Now, it could happen sooner for me, longer for you. We just don't know your health conditions. So all of our harnesses come integrated with suspension trauma straps. So once you take that fall, like I said, deploy your suspension trauma straps. You have one side with the hook, one side with the hoop. Grab that hoop down by your knee, drop them down, step into it. Now that buys you time to get rescued, okay? That's gonna relieve that pressure. Now, since you have a self-rescue, I don't have a hazard down here. Now I can go ahead, step out of my trauma straps, and go ahead and self-deploy. As you can see, I went down 1 meter per second, how softly I landed on the ground, okay?
And the same thing goes, if he wasn't able to pull the cord, the rip cord on his shoulder, this pole up here is the roll gliss pole. This is the actual pelican hook that you guys would be using. So you'd hook up a rope to this, open it up, it slides right inside. A little restraint system for it. This will go out to about 17 feet. So that red hook on the side of his pack, you could hook this onto that and it pulls out and locks itself. So now you've got a cord that's attached to that. Once it's attached, you won't need this anymore, but you'll be able to, if this was hanging there attached to his back, grab the cord, yank on that, and that would actually allow him to go down. The only thing is you got to make sure that you have enough rope on this for when he starts to descend, because you don't want that to end up hooking up and you know, changing his direction of fall or prohibiting him from getting to the ground. So be able to do that.
Any questions on how we deployed this unit? So ANSI requires us per 359 to test these units between weight ranges 130 and 310. So the upper weight range for this product is 310. We do have letters that you could use it for lower than 310 or lower than 130, but you don't want to go over that 310 mark with it. So when you're calculating your weight, it needs to be your body weight, your PPE, your tools you're working with as your total weight, okay? And that's what we go through an ANSI certification on, okay? Now the Rogliss over here, again, that's a 310, but 2-user system, up to 620. So let me get harness back up here.
If you guys had a job site too where you wanted to re-demonstrate this to somebody out there, the pack that I'm using right now is a trainer pack. So we would be able to come out to that job site, say if you got crew members that aren't here today and they really want to understand the practical application of this, we could rewind it ourselves, come out, as long as we have the ability to set this up and pretty much the same as it is here, we could do that there. So it's not a one-time thing. If you guys need refreshers or something like that, we could do it as well. I'm all hooked up, all good? All right.
Okay. You okay?
Yep.
Okay, so he just took a fall. He might be unconscious up there, hanging there, medical emergency. He might have hit the ledge, so he can't pull his ripcord. So like I said, we have our rescue pole here, Rogliss. I'm gonna come up. And grab on to that side ripcord. And now I can go ahead and pull, okay? You good to go?
Yep. So I think the longest one we have is 50 feet, right, Matt? So if we needed one for a higher application, we can go up to 100 feet, which would be a little scarier. But other than that, I mean, it's pretty quick. I mean, it's an easy drop. It's not much to it. Has anybody here ever been rock climbing and had the auto belay device? No, a couple. It's the same principle. It's just a controlled descent. Same as the Rollgliss R550. So if the Rollgliss was hooked up there as well, it'd just do the exact same thing. So it's a demonstration for both. The only difference is the Rollgliss, which we'll show in a minute here, has to be hooked up relatively near. If you're going to hook the actual unit up and hook somebody off to it, it would have to be close so that when you disconnect, you don't get a pendulum effect. But you can do redirects.
Yep. So we'll do that here. We're going to run over here and do a few drop tests now, and then we'll run through the Rollgliss system. So we're going to do 3 different drops today. We're going to show what the arresting forces are going to be depending on what device you're using. This is my dummy. His name's Fred. He weighs 221 pounds. Today, Fred didn't listen to our safety presentation. He's going to wear a 4-foot restraint lanyard for restraint-only purposes when he should be wearing a fall arrest device. He's going to take a 4-foot free fall on this device. What do you think the arresting force is going to be on his body at 4 feet? He weighs 221. So 4-foot free fall, 221. Anybody know what the arresting force is going to be? All right. 3, 2, 1. Let's give him a, there you go, drop. 3,410 pounds of force to the body there. At that level of force, arresting force, you're going to experience serious injury, okay? You're most likely going to have dislocated joints, internal injuries. It's not going to be a fun day for you, okay? Our next drop's going to be with another 4-foot lanyard, but this time we added a shock pack, so we can use it for fall arrest. Now, does anybody know what the fall clearance is needed for a 6-foot lanyard with a shock pack? 17 feet, I heard. Let's do some math real quick. So OSHA allows us up to how many feet on free fall? 6 feet, right? So here we're going to take a 6-foot free fall. So we have 6 feet, okay? Your shock pack's going to deploy up to another 4 feet. How many feet is that? 10 feet, right? Your body's going to stretch to the height of your D-ring. So you saw up there, that harness stretches, right? So that's about another 6 feet. Where are we at? 16 feet. OSHA requires another 1.5 foot safety factor. What's that total distance? 17.5 feet of potential fall clearance, right? Now here in the state of Washington, what heights do we have to start tying off at? 4 feet, right? 4 feet. So you're probably asking yourself, at 4 feet, how the heck would this keep me from hitting the ground? Well, that 17.5 feet of fall clearance, potential fall clearance, is from your anchor point. So one, we could either raise that anchor point to a higher level to get you that fall clearance, or we could use a shorter lanyard, or maybe a lanyard's not the right tool for the job. We could use a retractable or a personal retractable, which is going to get you as little as 4 feet of fall clearance needed. So I'm going to hook up my 4-foot lanyard here with the shock pack. We can use this for fall arrest. Now, where's that shock pack go? Does it go to my anchor point or me? It goes to your harness, right? We want to decelerate our fall. So I need to raise my anchor point now. So we just saw over 3,400 pounds of force to the body on a restraint lanyard. By adding a shock pack, what do you think the arresting force will be at this point? Half? Anybody else? So you're thinking 1,500, 1,600? Something like that? All right, 3, 2, 1, drop. 699 pounds of force, arresting force to the body there. You're probably asking yourself, how did we do that by adding a shock pack? Well, inside this shock pack, there's 2 pieces of webbing sewn together. At 600 pounds of force, these 2 pieces of webbing start pulling apart, decelerating your fall till you hit 0. You might ask yourself, well, what if I use this product incorrectly? I'm over the weight range, I take greater than a 6-foot free fall. What's gonna happen? These 2 pieces of webbing will continue to pull apart till it's one single strand while maintaining its 5,000 pound integrity, okay? OSHA requires us as a manufacturer to keep the maximum arresting force to 1,800 pounds or less to the body, okay? ANSI requires us to keep the average arresting force to 900 pounds or less to the body. So you can see when you're using the right device in your application, we're going to keep you well under that 1,800 pounds of arresting force to the body, and we're going to get you under that average of 900 pounds of arresting force to the body. Much more manageable, where you're going to have most likely be able to walk away without injury, okay? We'll do one more drop, and then we'll talk about the R550 rescue device. So our next drop's going to be on a retractable, similar like we have up there, okay? We're on a galvanized cable, no shock pack added. Now, how many falls is this good for? 1. How do you know if it's been in a fall? See that red dial? That's your impact indicator. Red is dead, right? That should be up like that with a ring around it. So this is showing it's been impacted, okay? So we just saw 699 pounds of arresting force to the body. By going to the retractable, what do you think we'll experience now? 2,400. Let's take a look here. 3, 2, 1, drop. 658 pounds of arresting force to the body. But everyone, more importantly, look at your fall clearance needed with that product. So the key takeaways here on these drops is when you're using the right products while working at heights, we're going to keep you well under that 1,800 pounds of arresting force to the body. We're going to keep you under that average of 900 pounds of arresting force to the body, but more importantly, we're going to keep you from hitting that lower level or the ground when you're working up there, okay? Any questions on the drops? All right, let's go ahead and start with the R550. Let me get set up here. We'll start talking about that. All right, so next item we're going to go over is the Rogless R550. It's our other rescue device. So it's a multi-purpose rescue device. So if you can't self-rescue, this is your next option. As you can see here, it's a bi-directional system. Dual braking system in there, so dual redundancy. You can raise people with this system, lower them. You can do redirect. So we're going to run through a few different rescue scenarios and show you how to use this product. First scenario is if you take a fall and you can reach your coworker's D-ring, okay? So you're going to pay this line out down to their D-ring and attach it to their D-ring. You could attach this R550 to their existing anchor point that they fell on. The reason we can do that is we know that anchor point's going to withstand that 5,000 pounds, okay? During rescue, our anchor points don't need to be rated for 5,000 pounds because that fall's already happened. That's already withstanding that fall. So if you can reach their back D-ring, go ahead, anchor this off to their anchor point, extend your line down to their D-ring, hook it on. Now what we need to do is transfer them from their current system that they're hanging on to the rescue device. So how you do that is you have 2 dog ears up here on this system, a marine cam cleat. You're going to take the other side that's not down on the rescue, run that through the dog ear, through your cam cleat, okay? Now you're ready to start your rescue. I'm going to start rotating my wheel back here. Also, with this system, if you're doing redirects or a lot of lifting or lowering, you could actually hook a power drill right there to the chuck. And I'll show you on a redirect here in a little bit. So I'm going to start rotating that wheel towards this side of the line that's hooked up to the person. And what my goal is here I'm transferring that load from their current system over to the R550. So you can see here I have slack already from me rotating that wheel. You want to go ahead and keep that pulled through as you're working that system. So you can see here now I have all that weight up here on my R550. I'm starting to get slack there. I'm going to keep lifting that person. Pulling the slack out. Until I have enough slack in their current device where I can disconnect it from their anchor point, okay? Or from their D-ring. So I'm going to go ahead and disconnect. Now when you let go of this wheel, don't just let go, because you'll see why. You're going to have to let a little slack out. So you just let it rotate through your glove a little bit, and everything will get stopped there, okay? If you just let go of the wheel, it's going to jolt that user. They've already been through a fall. It's a traumatic situation. You don't want to add more stress to them, right? So just hold on to that wheel until everything tightens up. So now you could either raise them back over the edge, or in this scenario over here, there's no hazard below. I could lower them down to safety. Now, to lower them down to safety, you just pop that out of the cam cleat there. I'm holding 220 pounds with 2 fingers here. Okay, you could either let it all go, let go of the rope. They're going to descend down at 1 meter per second, just like what we saw in the self-rescue device, or I could slowly guide them down as slow as you want, or just let go. Okay, that's scenario 1, if we can reach them. Say they're down 10 feet. You can't pay out line, you can't reach their D-ring, so now you would use your rescue pole. Okay, you're going to slide this in, this hook, into that channel there to keep that gate open. And I'll show you what we're going to do here next. So in this scenario, say you're on that perimeter limiter, you're using a leading edge product. If you take a fall, you're probably going to have about 14, 16 feet of fall clearance there. So I can't reach you by just reaching down and getting your D-ring, okay? So I need to utilize our rescue pole. So you can see there, we take the rescue hook, slide it through that channel, it keeps our gate open. I'm going to hook the R550 right here to our rescue hook, okay? That now allows me to extend this pole down to the user and connect onto their D-ring, okay? Now you can start the rescue process, just like you saw before. Next scenario is going to be, say you're working on a side of a structure, you're 50 feet down on that structure, you take a fall. Well, I can't reach you with my rescue pole because this only goes up to 16 feet, right? So I can't get to you that way. I can't reach down to your D-ring, you're way too far down. Next scenario would be as if you're on a lifeline. I can take a rope grab, one of our rescue rope grabs. So this scenario is you're working on a vertical lifeline. This simulates your 3-foot lanyard to that lifeline, okay, for purposes. So now you can use, obviously we can't get to their D-ring. So now you could go about 4 feet over that edge that they're anchored off to that lifeline on, anchor your R550 to that anchor point, reach about 4 feet over the edge, and utilize our rescue rope grab, okay? The nice thing about our rescue rope grab, you're going to have a nice diagram here and shows you how to install that to the lifeline. It's going to show you which way it goes to the R550 and which way down to the user. Okay, so I'm going to go ahead and put this on. Now, another thing you want to do when you're going through the rescue process, I'm going to show you what could happen if you don't use carabiners. I have this installed on my lifeline. I'm in a panic. I'm trying to get him rescued or her rescued. I don't have that tethered off. Now you just lost your grab there all the way down to that user. Probably hit him in the head. Not feeling good. Always in your rescue pack. You can see different tools up here on my table here. You want to keep carabiners in your R550 kit because what you want to do is carabiner that off, or even before you attach that to the actual vertical lifeline, attach your R550, okay? So you can attach it just like that. Okay? Same process now. I'm going to go ahead and transfer over from their current system to our rescue device. Same principle. We're going to run that lifeline over the dog ear into the cam cleat and start that rescue process. So I'm going to start rotating towards my user, transferring over to the R550. While doing that, pulling out the slack. Now in this scenario, 50 feet down on a structure, we're most likely not going to get them back up over the top, so we're going to have to lower them down. So again, once we get them fully transferred, we'll lower them down to safety. You can see here, I'm getting slack on their current line. Again, don't just let that go. When you detach, hook it onto the R550, hold onto the wheel, let that slack out, and now you can lower them down to safety by popping it out of the cam cleat. Again, you can lower them down with 2 fingers or just let go of the rope. Okay? All right. Any questions on that scenario? Yeah, when you're talking rescue, like Matt said, you want to have a dedicated rescue team, practice it. We're solely showing you different scenarios how you can use this product. So the next one's going to be a redirect. And for redirects, it's going to be you take a fall. There might be, like I said earlier, a pool of alligators underneath you or acid you don't want to go down into. So we need to redirect that person from point A over here to get them down to safety, okay? So we'll go ahead and go through that scenario real quick. So doing redirects, this is going to be your most complex type of rescue. You're going to need multiple anchor points, you're going to need pulleys, and you're going to need these carabiners up here. So you have your micro pulley here that we're going to use. We're going to use a carabiner, and then we're going to need another anchor point. So I'm going to use a choker, okay? So I'm going to choke off down here to my anchor point. Now this becomes my anchor point for the R550, okay?
This would be the same kind of system for the redirect if we were using it up here. Say if I was standing on top of the Connex here and we had the R550 hooked up where one of the SRLs is, or I mean, sorry, if we had a block hooked up there and we hooked the R550 where I am, you could redirect the line over that, set it up beforehand before you get into a high hazard situation so that you have the unit there that you can actually control, but the line goes to another snatch block, drops down from there. You could use a pole to hook somebody off. So then you don't have to like put yourself in a precarious position to reach up and try and get an overhead anchor point. So that's what this would be good for, is if you were on a platform and you needed to get somewhere else, you could set it up beforehand too, which might be the easiest way to do it. If you guys go up to Alaska or Anchorage or something like that, if you're working underneath the platform, that would be the system that we would use, because you couldn't hook it up to the same scaffold that you're standing on, because if it's hooked up at foot level, you could only bring somebody up about 2-3 feet below where that anchor point is. So you'd have to hook it up somewhere else or run the rope up to a different anchor point. So
as you can see, a redirect is going to be your most complex rescue. You have multiple anchor points here. I have my R550 anchored down here. I have my pulley anchored off up here, running down to the user, okay? On redirects, I highly recommend using a power drill because there's going to be a lot of twisting on that wheel. So to use a power drill, just hook it right into your chuck and lock it on, okay? Same setup. You're going to run that line through your dog ear into the cam cleat. And you're just going to start rotating that wheel with your drill. As that drill is rotating that wheel, you're going to have slack that you're going to want to pull out, okay? You can go as slow as you want or as fast as that drill wants to go. And you can see now I'm redirecting that person from over there to over here to lower them down to safety. Okay. Now when you're done with your redirect, you have them over to safety. You're 100% on your R550. Don't just let go of this wheel because now this drill, there's an extreme amount of torque on here. It's going to be flipping around. So go ahead and loosen your drill on that chuck, holding that wheel with your other hand. Pull that drill off. Now let the slack out. And now you're ready to lower them back down to safety. Okay? Any questions on R550 use? Anybody want to experience being lowered on an R550? We can do that. All right, everyone, thanks for coming out today and viewing our demonstration in the self-rescue pack by DBI Sella and the demonstration of our Rogueless R550 and watching the drop test that we performed today. Key takeaways here: when you're using the right products in your application, we're going to protect you from hitting that lower level or the ground and keep you under those maximum arresting forces allowed by OSHA. So thanks again for your time today, everyone.